Welcome to Suresh Bhatt classes. We are solving question on quantitative aptitude topic numbers. All the topic of quantitative aptitude are useful for many competitive exams like Bank PO, RRB, SSC CGL, Railways and many government job exams and job interviews. Also, these topics are useful for many entrance exams like GRE, SAT, ACT, CAT, GMAT and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are solving questions on factors. Our question is, if n equal to 16 to the power 8, then n is divisible by how many perfect squares? The given options are option A 15, option B 16, option C 17, option D 19. Before solving this question, I request you to please subscribe to this channel. The given number can be written as 2 to the power 4, as 16 is 2 to the power 4 to the power 8. This is equal to 2 to the power 2 to the power 8 times 2 is 16. The total power of 2 is 8 times 4 is 32. Here also 2 times 16 is 32. So the given number is 2 to the power 2 to the power 16. Now 2 to the power 2 is a perfect square and the power of this is 16. So the number of factors are 16 plus 1 equal to 17. And from the given options, our answer is option C 17. In such type of questions, we have to make the prime number a perfect square and then whatever may be the power of that perfect square, we have to add 1 to that power. Here the 2 to the power 2 is a perfect square. Now the power of 2 to the power 2 is 16. So the factors will be 16 plus 1 equal to 17. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, how many factors of 3 to the power 9 multiplied by 5 to the power 4 multiplied by 7 to the power 5 are perfect square? The given options are option A 36, option B 30, option C 24, option D 45. Before solving this question, I request you to please subscribe to this channel. We make a perfect square of the given number. We take out the perfect square quantities from the given number. 3 to the power 9 can be written as 3 multiplied by 3 to the power 8 and 5 to the power 4 is 5 to the power 4 and 7 to the power 5 can be written as 7 multiplied by 7 to the power 4. Now we can easily make the numbers a perfect square. So 3 multiplied by 3 to the power 8 can be written as 3 multiplied by 3 square to the power 4 multiplied by 5 to the power 4 can be written as 5 square to the power 2 and 7 multiplied by 7 to the power 4 can be written as 7 to the power 2 to the power 2. Now we take out all square quantities which are 3 to the power 2 to the power 4 multiplied by 5 to the power 2 to the power 2 multiplied by 7 to the power 2 to the power 2. Now 3 to the power 2 is a perfect square, 5 to the power 2 is a perfect square and 7 to the power 2 is a perfect square. Now we add 1 to each power of these quantities. The 3 to the power 2 has power 4. So we add 1 to this 4 and this is 4 plus 1 into 5 to the power 2 has power 2. So we write 2 plus 1, and 7 to the power 2 has power 2. So we again write 2 plus 1, and this is equal to 4 plus 1 is 5, multiplied by 2 plus 1 is 3, multiplied by 2 plus 1 is 3, and this is equal to 5 times 3 is 15, and 15 times 3 is 45. So there are 45 factors which are perfect squares of the given number, and from the given options our answer is option D, 45. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, if number n has 462 factors, then what can be the maximum number of prime factors of n? The given options are option A 5, option B 6, option C 3, option D 4. Before solving this question, I request you to please subscribe to this channel. We know that if n equal to a to the power p into b to the power q into c to the power r into d to the power s, and we continue like this. Here a, b, c and d are prime factors, and p, q, r and s are their powers. The number of factors will be p plus 1 multiplied by q plus 1 multiplied by r plus 1 multiplied by s plus 1, and we continue like this. Now this value p plus 1 into q plus 1 into r plus 1 into s plus 1 and so on, we continue like this, is equal to 462. So we factorize 462. We divide 462 by 2. So it is 231. Now this is not further divisible by 2. We divide it by 3. 3 divides 21 for 7 times, and 23 minus 21 is 2. We carry 1. 3 again divides 21 for 7 times. Now it is divisible by 7, and it divides 77 for 11 times. So the factor of 462 are 2 multiplied by 3 multiplied by 7 multiplied by 11. So p plus 1 is 2. Therefore p equal to 1. Q plus 1 is 3. So q equal to 2. R plus 1 is 7. So r equal to 6. And s plus 1 is 11. So s equal to 10. Now no further factors of 462 are possible. So we can write it as a to the power 1 multiplied by b to the power 2 multiplied by c to the power 6 multiplied by d to the power 10. And a, b, c and d are prime factors. So there are 4 prime factors which are a, b, c and d are possible. And from the given options, our answer is option D 4. So there are maximum number of prime factors of n, which is 4. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find total number of factors of 2 to the power 21 plus 2 to the power 22 plus 2 to the power 23 plus 2 to the power 24 plus 2 to the power 25. The given options are option A 32, option B 36, option C 40, option D 44. Before solving this question, I request you to please subscribe to this channel. We can write this number as, we can take 2 to the power 21 common from the given number, and it leaves inside the bracket 1, plus if we take 21 common from 22, 2 to the power 21 from 2 to the power 22, then the value remain is 2, plus when we take out 2 to the power 21 from 2 to the power 23, then it will be 2 to the power 2 and 2 to the power 2 is 4, plus we take 2 to the power 21 from 2 to the power 24, then we have 2 to the power 3 and 2 to the power 3 is 8, plus when we take out 2 to the power 21 from 2 to the power 25, then the quantity remains is 2 to the power 4 and 2 to the power 4 is 16, and this is equal to 2 to the power 21 multiplied by 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15, 15 plus 16 is 31. So we can write it as 31 to the power 1. Now number of factors are power plus 1. So 2 to the power 21 can be written as 21 plus 1 and multiplied by 31 has the power 1. So 1 plus 1 is 2. So this is equal to 22 multiplied by 2 equal to 44. So there are 44 factors of given number, and from the given options our answer is option D, 44. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, a number n has 12 factors. Find the minimum value of n. The given options are option A 40, option B 45, option C 48, option D 60. Before solving this question, I request you to please subscribe to this channel. If n is equal to a to the power p multiplied by b to the power q multiplied by c to the power r, and this continues, where a, b and c are prime numbers and p, q and r are the powers of these prime numbers, then total number of factor is given by p plus 1 into q plus 1 into r plus 1, and this continues. So this p plus 1 into q plus 1 into r plus 1 is given to us is 12. If we have only one factor, then if p plus 1 is 12, then p equal to 11, and if it has the power 11, then it will be a big number. So it cannot be a minimum value of n. And if we take these two, p plus 1 and q plus 1, and if this is equal to 12, then one has to be 4 and other has to be 3. If p plus 1 is 4, then p equal to 3 and q equal to 2. Again, this will be a big number. So what we have to do? We have to factorize 12 into small factors. 12 can be written as 2 multiplied by 2 multiplied by 3. If we take p plus 1 equal to 3, then p will be equal to 2. If we take q plus 1 equal to 2, then q equal to 1. And if we take r plus 1 equal to 2, then r equal to 1. The smallest prime numbers are 2 multiplied by 3 multiplied by 5. These are the three smallest prime numbers. And now we have to put the powers to it. So we have to put maximum power on the smallest number, which is 2. So we will make it 2 to the power 2, then 3 to the power 1 and 5 to the power 1. So this number comes out to be 2 to the power 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. So the smallest possible number which has 12 factors is 60. And from the given options, our answer is option D, 60. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the number of factors of 7 to the power 13 multiplied by 9 to the power 10 multiplied by 12 to the power 9 multiplied by 15 to the power 6 multiplied by 20 to the power 5 multiplied by 25 to the power 7, which are simultaneously perfect squares and perfect cubes. The given options are option A 150, option B 450, option C 320, option D 360. Before solving this question, I request you to please subscribe to this channel. The given number has to be factorized into prime factors, and we can write it as 7 to the power 13 as 7 is prime number, multiplied by 9 can be written as 3 to the power 2. So 9 to the power 10 will be 3 to the power 20. 12 can be written as 2 to the power 2 multiplied by 3. So 12 to the power 9 will be 2 to the power 2 as power 9. It will be 2 to the power 18 and 3 to the power 9 multiplied by 15 to the power 6. 15 can be factorized into 3 multiplied by 5. So it will be written as 3 to the power 6 multiplied by 5 to the power 6 multiplied by 20 can be written as 4 multiplied by 5, and 4 can be written as 2 to the power 2, and 20 to the power 5. So 2 to the power 2 times 5. 2 times 5 is 10. So it will be 2 to the power 10 multiplied by 5 to the power 5 multiplied by 25 can be written as 5 to the power 2. So it will be 5 to the power 7 times 2 is 14. So 25 to the power 7 can be written as 5 to the power 14. Now we have all prime numbers. So we properly arrange it from lowest to highest prime numbers. So this will be 2 to the power 18 multiplied by 2 to the power 10. So we will add their powers. 18 plus 10 is 28 multiplied by 3, and power of 3 we count. 3 to the power 20 multiplied by 3 to the power 9 multiplied by 3 to the power 6. So we add the powers. 20 plus 9 is 29 plus 6 is 35 multiplied by 5. Now we will count the powers. 5 to the power 6 multiplied by 5 to the power 5 multiplied by 5 to the power 14. So we add the powers. 6 plus 5 is 11 plus 14 is 25. So it will be 5 to the power 25 multiplied by 7 and 7 to the power 13. Now we have to make the factors which are simultaneously perfect squares and perfect cubes. So that number must have power 6, because power 6 can be converted as perfect square as well as perfect cube, which I am explaining you. If say A is a number, has power 6, then this can be written as A square to the power 3, which is perfect cube, or this can be written as A cube to the power 2 is a perfect square, because the power in first case is 3, which is perfect cube, and in second case A to the power 3 to the power 2 is a perfect square. So we have to take out the prime numbers with multiple of power of 6. This 2 to the power 28 can be written as 2 to the power 4 multiplied by 2 to the power 6 to the power 4. So it will be 6 times 4 is 24 plus 4 is 28. Now 3 to the power 35 can be written as 3 to the power 5 multiplied by 3 to the power 6 to the power 5. So this will be 6 times 5 is 30 plus 5 is 35. So it will be 3 to the power 35. And 5 to the power 25 can be written as 5 multiplied by 5 to the power 6 to the power 4. So it will be 6 times 4 is 24, and 24 plus 1 is 25. Multiplied by 7 to the power 13 can be written as 7 multiplied by 7 to the power 6 to the power 2. So 6 times 2 is 12 plus 1 is 13. So this we have already converted into power of 6. Now those numbers which are power of 6, we separate them, and those are 2 to the power 6 to the power 4 multiplied by 3 to the power 6 to the power 5 multiplied by 5 to the power 6 to the power 4 multiplied by 7 to the power 6 to the power 2. Now the factors of these numbers are the power of 2 to the power 6 has power 4, so we can write it as 4 plus 1 multiplied by the power of 3 to the power 6 is 5, so it will be 5 plus 1 multiplied by 5 to the power 6 has power 4, so it is 4 plus 1 multiplied by 7 to the power 6 has power 2, so it will be 2 plus 1. Now this is equal to 4 plus 1 is 5 multiplied by 5 plus 1 is 6 multiplied by 4 plus 1 is 5 multiplied by 2 plus 1 is 3. So 5 times 6 is 30. 30 times 5 is 150. 150 times 3 is 450. Thus, the given number has 450 factors which are simultaneously perfect squares and perfect cubes. And from the given options, our answer is option B, 450. I hope you have understood the method of solving this question, and you can learn from this question how to solve such type of questions. We go to the next question. Our question is, a number n has 8 factors. Then how many factors of 2n are possible? The given options are option A 8, 12, 14, 16. Option B 9, 10, 12, 16. Option C 8, 9, 10, 12. Option D 10, 12, 15, 20. Before solving this question, I request you to please subscribe to this channel. 8 can have factors like 8 multiplied by 1 or 4 multiplied by 2 or 2 multiplied by 2 multiplied by 2. So we can get 8 if it is 8 multiplied by 1, or it is 4 multiplied by 2, or 2 multiplied by 2 multiplied by 2. We know that a to the power p into b to the power q into c to the power r, where a, b and c are prime numbers and they have power p, q and r. Then the number of factors are p plus 1 into q plus 1 into r plus 1. If 8 equal to 8 multiplied by 1, then it has only possible value is a to the power 7. Then 7 plus 1 will be 8. Or a to the power 3 into b to the power 1. Then 3 plus 1 is 4 and 1 plus 1 is 2. And 4 times 2 is 8. Or we can have a to the power 1 into b to the power 1 into c to the power 1. So the number of factors will be 1 plus 1 is 2 multiplied by 1 plus 1 is 2 multiplied by 1 plus 1 is 2. So it will be 2 multiplied by 2 multiplied by 2 equal to 8. So these are the values of n for having 8 factors. Now if it is 2n, then this will become 2 to the power 1 into a to the power 7, or 2 into a to the power 3 into b to the power 1, or 2 into a to the power 1, b to the power 1 and c to the power 1. So we can write 2 to the power 1 wherever there is a 2. Now if it is 2 to the power 1 and a to the power 7 and a is different than 2, then what we will have? We will have the number of factors 2 to the power 1, 1 plus 1 is 2 and 7 plus 1 is 8. 2 times 8 is 16. So number of factors will be 16. If it is 2 to the power 1, a to the power 3 and b to the power 1, then the powers are 1, 3 and 1. So 1 plus 1 is 2, multiplied by 3 plus 1 is 4, multiplied by 1 plus 1 is 2. So it is 2 times 4 is 8 and 8 times 2 is 16. And when it is 2 to the power 1, a to the power 1, b to the power 1 and c to the power 1, then all the powers are 1. So it will be 1 plus 1 multiplied by 1 plus 1 multiplied by 1 plus 1 multiplied by 1 plus 1. So it will be 2 multiplied by 2 multiplied by 2 multiplied by 2. Then again number of factors will be 16. Here a, b and c are different than 2. Then we will have 16 factors. Now when a equal to 2, then 2 into a to the power 7 will be 2 to the power 7. So it will be 2 to the power 8. And number of factors will be 8 plus 1 is 9. Also, when it is 2 to the power 1, a to the power 3 and b to the power 1, then it will be 2 into a to the power 3 is 2 to the power 3 and b to the power 1. Then number of factors will be, it will be 2 into 2 to the power 3 will be 2 to the power 4 and b to the power 1. Then 4 plus 1 is 5 and 1 plus 1 is 2 and 5 times 2 is 10. So number of factors will be 10 and 2 to the power 1, a to the power 1, b to the power 1 and c to the power 1 will become 2 into value of a is 2 into b to the power 1 into c to the power 1 will give us 2 and 2 becomes 2 to the power 2. So number of factors will be 2 plus 1 is 3, multiplied by 1 plus 1 is 2, multiplied by 1 plus 1 is 2. So 3 multiplied by 2 is 6, multiplied by 2 is 12. Now if b equal to 2, then b is involved in 2 to the power 1, a to the power 3 and b to the power 1. So that will be 2 into a to the power 3 and b equal to 2. So it will be 2 to the power 1. So this will become a to the power 3 and b to the power 2. And 3 plus 1 is 4 and 2 plus 1 is 3 and 4 times 3 is 12. So we will have factor 12. Or when b equal to 2, then we can have 2 a to the power 1, b to the power 1 and c to the power 1. Here in place of b I am writing 2 because b equal to 2. Then number of factors will be a to the power 1 and in place of b it is 2. So 2 to the power 2 and c to the power 1. So it will become a to the power 1, b to the power 2 and c to the power 1. Then the number of factors will be 1 plus 1 as a has power 1. So it will be 1 plus 1 is 2. B has power 2. So it will be 2 plus 1 is 3. And c has power 1. So 1 plus 1 is 2. So 2 multiplied by 3 is 6. Multiplied by 2 is 12. So number of factors will be 12. If c equal to 2, then again it will be the same, because whether b is 2 or c is 2, the value doesn't change. So it is going to be 12. So now how many types of factors we have? 9, 10, 12 and 16. So we have 4 factors of 2n are possible, which are 9, 10, 12 and 16. And from the given options, Our answer is option B, 9, 10, 12 and 16. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, if 2n has 8 factors, 3n has 9 factors, find number of factors of 6n. The given options are option A 11, option B 10, option C 12, option D 15. Before solving this question, I request you to please subscribe to this channel. If 2n has 8 factors, 8 can be 4 multiplied by 2, and then 2n can be, then 2n is equal to a to the power 3 and b to the power 1. So that 3 plus 1 is 4 and 1 plus 1 is 2. So it becomes 4 multiplied by 2 and there will be 8 factors. This is only possible when a equal to 2. Now we keep this in mind that a is equal to 2. Now 3n has 9 factors. So 9 is 3 multiplied by 3 and 3n can be equal to a to the power 2 into b to the power 2. Then only 2 plus 1 is 3 and 2 plus 1 is 3. So 3 times 3 is 9 factors are possible. Now here 3 is there, 3n. It means that b must be 3. Then only it is possible, because in 2n, 2 has to be merged either with a or b, then only this is possible. But if b is 2, then the power of b should be 2, but the power of 2 is 1. So only a has to be merged with 2. So a must be equal to 2. And in 3n, 3 is to be merged with a or b. But we have discussed that a must be 2. So here 3 has to be merged with b, so that the power of b becomes 2. So a equal to 2 and b equal to 3. Then what is n equal to? A to the power 2 and b to the power 1, because a to the power 3 has become when a equal to 2. N must be equal to 2 to the power 2 and 3 to the power 1. Then only 2n can have a to the power 3 and b to the power 1, and 3n can have a to the power 2 and b to the power 2. Then what can be? 6n. So we multiply it by 6. So it becomes 6n equal to 6 multiplied by 2 to the power 2 and 3 to the power 1. So this is equal to, 6 can be written as 2 multiplied by 3 multiplied by 2 to the power 2 multiplied by 3 to the power 1. So this is equal to 2 to the power 3 multiplied by 3 to the power 2. Now, how many factors of this are possible? So we have to add 1 to every power. So 3 plus 1 is 4 multiplied by 2 plus 1 is 3. So number of factors will be 4 multiplied by 3 equal to 12 factors. And from the given options, our answer is option C, 12. Let me explain this question again so that there is no confusion in your mind. If the number of factors are 8, then it can be 4 multiplied by 2 and 2n can be a to the power 3 and b to the power 1. Then only the number of factors will be 8, as the power of a is 3. So 3 plus 1 is 4 and power of b is 1. So 1 plus 1 is 2 and 4 multiplied by 2 is 8. So this way the value of 2n is a to the power 3 and b to the power 1. But here it is 2n. It means that one of it, either a or b, must be 2, so that 2 is merged in it. B cannot be 2. If b is 2, then the power must be b has value 2 and this 2. So the power of B must be 2, but the power of B is 1. So A must be 2 because 2 is merged in A. So we take A equal to 2. Now the 3n has 9 factors. So it can be written as 3 multiplied by 3. So 3n has value a to the power 2 and b to the power 2. So that the factors is 2 plus 1 is 3, and again power of b is 2 and we add 1 to it. So 2 plus 1 is 3. So this becomes 3 multiplied by 3 equal to 9. Now where this 3 has gone? The 3 has merged with b. So b must be equal to 3. And as we have already discussed that a equal to 2, then only b has to be 3. Now a equal to 2 and b equal to 3. Then what will be the value of n? If 2n has power a to the power 3 and b to the power 1, it means that 2 has merged in a. So n is a to the power 2 and b to the power 1. So this is equal to 2 to the power 2 as a equal to 2 and b is 3. So it is 3 to the power 1. Now what will be 6n equal to? 6n equal to 6 multiplied by 2 to the power 2 and 3 to the power 1. 6 can be written as 2 multiplied by 3 multiplied by 2 to the power 2 and 3 to the power 1. So this is equal to 2 to the power 3 and 3 to the power 2. Now number of factors. We have to add 1 to every power and multiply them. So the power of 2 is 3 and we add 1 to it. So 3 plus 1 is 4, which we have written here, and the power of 3 is 2. So 2 plus 1 is 3. So we have written here, and 4 multiplied by 3 equal to 12 factors. So number of factors will be 12 and the value is 6n. And from the given options, our answer becomes option C, 12. I hope you have understood the method of solving such type of questions. If our logics are clear, then we can solve such type of questions very easily. We go to the next question. Our question is, if 2n has 15 factors, 3n has 16 factors, find the number of factors of 6n. The given options are option A 18, option B 20, option C 22, option D 24. Before solving this question, I request you to please subscribe to this channel. 2n has 15 factors. 15 equal to 5 multiplied by 3. So there are only 2 factors of 15. This gives 2n equal to a to the power 4 and b to the power 2. If a has power 4, then it has 4 plus 1 factors, and b has power 2, then it has 2 plus 1, that is 3 factors, and that gives 5 multiplied by 3. Now 3n has 16 factors. 16 equal to 4 multiplied by 4, and this gives 3n. It means that if the factors are 4, therefore the power of a is 3, and also it is 4 multiplied by 4. It means that the power of b is also 3. Now if we observe these two, a to the power 4, b to the power 2, and a to the power 3 and b to the power 3. Earlier the power was 2, b to the power 2, and then the power of b increases and it becomes b to the power 3. It means that 3 is merged in b. That's why the power has increased by 1. This gives the value of b equal to 3. And the power of a is reduced by 1. So it has become a to the power 3 as 2 is not here. It is 3. It means that when it is 3n, the power of a is 3, and when it is 2n, the power of a increases by 1. So it becomes a to the power 4. This means that a has value equal to 2. I hope you have understood both the logics of getting the value of a and b. Therefore, n equal to a to the power 3, as we have taken out 2 from n. So the power of a has decreased by 1 and it has become a to the power 3 and b to the power 2. And a to the power 3 can be written as 2 to the power 3 and b to the power 2 can be written as 3 to the power 2. Therefore, 6n equal to 6 can be written as 2 multiplied by 3 and n is 2 to the power 3 multiplied by 3 to the power 2. This gives 6n equal to 2 to the power 4 multiplied by 3 to the power 3. If the power of 2 is 4, then the factors will be 4 plus 1, and power of 3 is 3, then the factors will be 3 plus 1, and 4 plus 1 is 5 multiplied by 3 plus 1 is 4. This gives number of factors equal to 5 multiplied by 4, that is 20. So there will be 20 factors of 6n. And from the given options, our answer is option B, 20 factors. I hope you have understood the method of solving this question and the logic involved in this question. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.